Okay, so on this example, we're saying the angle of elevation of the sun is decreasing at 1/6 radians per hour. A building of height 66 meters casts a shadow which is lengthening as the sun goes down. Okay, so what is it we're even talking about? Let me draw a little picture so of what we have going on. And maybe I can just put it right over here. So yeah, and we have a building over here. All right. And we have the sun up in the sky. Oh, it's certainly weird now. I don't know. Okay, good enough. So, and the sun casts its rays down like that. Oops, I missed a little bit. Let me try that again. Not quite. I keep kind of just. No, it's even worse. One more attempt. All right, good. All right. So the sun's rays, right, are being blocked, and right there, from here to here, there is a shadow on the ground. As the building over here, this is the building. As the building blocks the sun's rays, makes a shadow on the ground. Okay. And then it says, write an equation, left side, right side, relating theta, the angle of elevation of the sun, and x is the length of the building shadow. So this is x down here, and this is theta right here. That's the angle of elevation. Angle of elevation. That means from flat up to the line aiming right at the sun. It's called the angle of elevation, in this case, to the sun. So that means whenever they say angle of elevation, it means from flat. So from flat, go up to the angle that points right at the sun. That's the angle of elevation of the sun there. Okay, and the building is height 66 meters. So let's put that over here. This is 66 meters tall building. Okay. Well, you know how this works, right? So from this, we need an equation. From this angle theta, this side here is the opposite of the angle theta. So this is the opposite side. This is the hypotenuse. Why? Because it's across from the right angle. Here's the right angle. We're assuming that building is straight up and down. And then that means this side down here is the adjacent side, right? So we have the opposite side from the angle theta, the hypotenuse, which is across from the right angle. This side's the adjacent. So we're thinking of SOHCAHTOA. Remember from your trigonometry days, SOHCAHTOA. That's how we know if we're supposed to use sine, cosine, or tangent. So which two do we have? We have x here, which is the adjacent, and 66, which is the opposite. So we don't know anything about the hypotenuse. So the numbers and the letters we're dealing with are the 66 and the x, which are opposite and adjacent. Which trig function uses opposite and adjacent? That'd be tangent. Tangent uses opposite and adjacent. So that's why our formula here is tangent of theta is opposite 66 over adjacent x, right? That's opposite over adjacent. Tangent is opposite over adjacent. That is opposite over adjacent. 6 over x. So there it is. That's our equation relating theta and x only. It's a connection between theta and x. Step two, when the angle of elevation of the sun is pi over 5, so when this angle right here becomes pi over 5, what is x? How do we find x? Well, if I take that little equation, take a tangent theta is 6 over x, and I multiply both sides. I'm trying to solve for x, right? By x cancels out here, and I get x tangent theta is 66. And then next I divide by the tangent. And by the way, let's put in that theta. What is that theta? Pi over 5. Boom, boom. So x will then equal 66 over tangent pi over 5. Maybe I should have put it in. That kind of maybe looks weird. Just you can speed theta here and then plug in that theta because they told me theta is pi over 5. All right, so what does that equal? 66 over tangent pi over 5. Let's go to Desmos. 66 over tangent pi over 5. Okay. 66 over tangent pi over 5. Yeah, now look, I'm in the wrong mode. See, I'm in degree. I go to radian, right? Pi over 5 is a radian angle. There it is, 90.8412. And that indeed is the answer, 90.8412. Okay, now, final question, hardest question. How fast is the shadow cast by the building lengthening when the angle of elevation is pi over 5? Okay, so you probably remember the steps. So step one, find the rate letters. We've already done that. The rates they speak of, you read the words here. Decreasing 1/6 radian per what is? Angle of elevation. So that's d theta dt. And that's negative 1/6 because it's decreasing. Decreasing means negative, going down. That angle's going down. And that makes sense, right? As the sun goes down, that angle goes down. That angle is decreasing. It's getting to be a smaller and smaller angle. The change in theta over time, the change in that angle over time is negative. It's going down. Okay, what other rate do they speak of? No more rates. This is the height. And keep reading. Da, 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 right here. How fast is the shadow cast lengthening? So they want to know dx dt because x is the length of the shadow. And they want to know how fast it's changing over time. So those are the two rate letters. So you identify those first off. Step two, write an equation with only those letters. Write an equation with only those letters, meaning x and theta, and that we did. We got that right here. So that's tangent theta is 6 over x. Got that right there. See, it only has theta and x. Okay, and then step three is always d dt, both sides of that bad boy. So we got to come in and go, okay, I'm going to d dt this side, and I'm going to d dt that side. But actually, we want to rewrite this to make it easier as, well, here, let's just take it slow. Let me do the tangent first. What's the derivative of tangent? Tangent is secant squared theta times d theta dt because of the chain rule, right? Theta is not the same as t, so chain rule d theta dt. Did the outside, your tan secant squared, keep the inside the same at first, times the derivative of the inside, d theta dt. Chain rule equals. Now for the other side, remember this is 66x to the minus 1. We don't want fractions that have x in them. We never want fractions with x in them because then we'd have to use the quotient rule. We hate the quotient rule. Want to avoid it when we can. Rewrite it that way, then take the derivative. So down comes the minus 1 minus 66x to the minus 2, right? Subtract 1 from the power. But then times root of the inside, chain rule, dx dt. Okay. So we did that, derivative both sides. Now step four, plug in the numbers. Plug in whatever other numbers you need. Now, what are we trying to find? We're trying to find how fast is the shadow lengthening. We're trying to find dx dt. That's what we want to get alone. Okay, so how do we do it? Well, we're going to get that alone. We're going to divide both sides by the minus 66, x to the minus 2 minus 66, x to the minus 2. Oops. So, oops, sorry about that. Boom, boom. There we go. So, dx dt. Now, this is easier said than done. We're sort of there, but we're sort of not. Got a little bit of work to do. Secant squared. Remember how that works? You remember the trig relationships? Sine, cosine, tangent, and then if you flip them, flip, you get cosecant, secant, cotan. So cosine and secant are the flip of each other. That's F stands for flip. So secant squared there is 1 over cosine squared. Let's stick in the angle theta now. Remember what theta is? Right up here. Theta is pi over 5. Pi over 5 times d theta dt. There's that minus 1/6. Right, right there. Right there. 1 over cosine squared. The bottom, minus 66. And now what is x? We got to get x. How do we get x? Well, that's a little tricky. Yeah. To get x, oh, we got x right here. Yeah, there we go. Where was it? We got x back in this step, didn't we? Boom, right there. Right there. 90.8412. 90.8412. But don't forget, that's to the negative 2 power, right? So there we go. Let's go to Desmos to make it happen. 1 over cosine squared pi over 5. Let's go. So, 1 over, and cosines, got a cosine squared of pi over 5. Square that. 1 over cosine squared of pi over 5. Let's go back. 1 over cosine squared of pi over 5 times negative 1/6 times negative 1/6 over negative 66 times the previous answer to the negative 2. Wait, I already forgot. Was it negative 66? And negative 66. Okay. It was. So negative 66 times. Now I'm just going to take the last answer. See, I see it's the previous thing. Okay, that answer, that's that 90, whatever, to the power of negative 2. Enter. There it is. 31.8386. 31.8386. Hopefully that's our answer. Yes, indeed. 31.8386. There it is. So it's kind of a complex type of thing, especially you got to remember this to the negative 2. But that was just the answer that we'd gotten previously for the X answer. So I just used Desmos and used the answer button. That made life easy, but it would have been easy to forget the negative 2 power. And so there we go. That means that's how fast the shadow is getting longer. It's getting longer by 31.8 meters every hour. And so there we go.